Hello, let me show you around the control engineering lab which we have developed. I'm going to walk over to all the stations slowly and come back to this one. So I'm going to show you there are 24 stations which is being mounted with PLC, VFD, servo motor, servo drives and a vision camera. And as well as we have an HMI. So I'm going to go over to the station and show you some of the working and details of the PLC lab. So here what we can see is this station is right now on, and main PLC is Compact Logix 1769 L18ERM BB1B. That's the bulletin number of the PLC. This PLC is 32-bit PLC and it is having 16 embedded IOs, and as well as we have 2-point IOs which is analog in nature. One is analog input and the other one is analog output. Both are 2-channel analog input and output. Apart from that, this particular Compact Logix PLC is a motion controller as well. That's why the M stands for the motion controller. In this station, you can also see that we have a VFD. The VFD is PowerFlex 525. It is capable of controlling speed and torque of an AC motor which is attached to this PowerFlex drive. Then you can see a servo drive. Servo drive is also Allen Bradley, and the name of the servo drive is Kinetics 350. It is based on controlling the servo motor, which is here, which is connected with a feedback signal and the power signal cord. This servo motor can be also controlled via your motion controller, and it can be also controlled through your servo drive. So we have programs inside our class in which students program the servo drive access or servo motor access through the PLC programs. Next, you can see a Cognex camera. This is a very basic Cognex camera which is Ethernet communication through the Ethernet. And basic means this is a black and white camera. Our students go on the basics how to program the Cognex camera using the PLC as well. So we are here connecting main motion controller with VFD, with servo drive, with a camera, and we do not forget about the HMI as well. So we have a panel view 5310 HMI, which is a colored HMI, and it is capable of developing 255 screens altogether. Let us talk about a little bit demo on the PLC. Right now on the screen you can see a PID going on for the temperature control. So you can also see that there is a PID box right here. This PID box is developed in-house via our AENT students. In the PID box, there is a temperature sensor, and there are two different analog outputs. One is a lamp and the other one is the fan. This PID is used for regulating the temperature of the box. If the temperature is less, then the lamp will glow a little bit brighter. If the temperature is more, it is going to cool off using the fan. I'm going to change the set point of the temperature control PID here, and right now the set point is 72 and the process variable is 76. So it is trying to cool off to 72. That's why the fan is running. You can hear the fan. Now let's try putting it up to 85 degree Fahrenheit and see what happens. So if I put it to 85 degree Fahrenheit, you can see the lamp starts glowing up. That means the lamp is trying to heat the temperature sensor inside. So this is one of the quick demo that we can do to introduce the students for the PID. They learn basics of the PID, a little bit of calculation. How do you go and calculate what kind of P, what kind of I, and what kind of D can be introduced in the system. That's all.